After we set up for a new project, the first thing we need to do when designing an irrigation project is design the lateral. Later on we will design also the submain, the main line, and have a look at the system summary, but the first thing we need to do is design the lateral. We have option here to use between integrated lateral and an online lateral with a micro sprinkler or a sprinkler. For our example, we will be using a T-tape product. Let's say we want to design using a 22mm T-tape 8mm product, let's say 340 liters per hour per 100 meter, and the spacing of 0.3 meters. So this is the product we have selected, the 708-30-340 T-tape. Next, we go over to calculating the run length. We have two options here. Either we can define a certain length that we want to check the uniformity, or we can give it a target uniformity for which the software will calculate the desired uniformity, the maximum run length. Let's start with the first option. Let's say we want to irrigate 200 meters. Let's say our lateral has 200 meters. We click on calculate, and immediately the software tells us that if we apply a 3.45 meters at the lateral inlet, and we see this represented also graphically here. So if the pressure of 3.45 meters is applied at the beginning of the lateral, at the end of the lateral, we will have 2.8 meters, which is the minimum required pressure for this specific product, for the T-tape. We see here that the product has this internal diameter, this spacing, this minimum pressure, this maximum pressure. So after we click calculate, we see that if we apply this pressure at the inlet of the lateral, the emission uniformity will be 92.95%. This will be the DU. We have the maximum velocity, the head loss, the total flow inside one lateral. And here we have the minimum and maximum pressure that we will see in this lateral. We can also click on show report, and the software will give us a detailed report of what is happening in the field. This first part here describes what is happening alongside one lateral. So we see here the emission uniformity, the delta flow rate, the nominal pressure, and so on. And if we start to scroll, we will see a detailed report of what is happening with each dripper in this lateral. So this is the first dripper, the second dripper, the third dripper, because we see here this is the spacing that we choose. And for each of these drippers, we see the inlet pressure, the flow, the velocity, the head loss, and so on. So this is a full report that you can use. We can even export to Excel. And this is something you can go and present to your customers or farmers. The second option in calculating run length is maximum length. For this option, you need to define the desired emission uniformity, let's say 85%. When doing a new calculation, please remember to delete the value in the inlet pressure, either by deleting it, either by writing it 0, or by clicking reset. So let's say we want to check what is the maximum run length for our product in order to achieve a minimum of 85% emission uniformity. Click on calculate, and immediately we have the results. 340 meters is maximum length that we can go to achieve this uniformity, and the values that we have here. So in order to achieve 85% emission uniformity on 340 meters, we need to apply 5.9 meters at the lateral inlet, and this will make sure that we still have the minimum pressure required for the lateral to work of 2.8 meters at the end of the lateral. Of course, we can play with these values. Let's say we want to test for 90% emission uniformity, click reset, click calculate. We can go 263 meters. You have different options of uniformity that you can check. Emission uniformity is normally something we use for tape, but you can also use flow variation for drip lines, or even a variation of pressure if this is something you want to design with. For T-tape and tapes in general, we recommend emission uniformity. We can also define slopes in case we have slopes in our field. Let's say we want to define a slope of So for our 200-meter lateral, we have a slope of 1% uphill. So the software will calculate the elevation of 2 meters. We add this here, we click reset, we go to define length. Let's say that we have these 200 meters. Click on calculate, and the software shows us that in order to achieve in order to irrigate 200 meters with this slope, uphill slope, we need to apply 5 meters, 5.6 meters at the lateral inlet, and this will give us only 80% emission uniformity. This is not something ideally necessarily. We normally like to have 85% emission uniformity or above. So let's see what happens if the slope is downhill. Select downhill, select reset, select calculate, and the software will tell us that we need to apply 2.7 meters at the lateral inlet, and because the slope is downhill, of course pressure will build up, so at the end of the lateral we will have 4 meters and the emission uniformity will go higher, so we will have 88% emission uniformity. You can even play and add more slopes. Let's say we want to add for the first 100 meter a 1% downhill slope, and for the second 100 meters we want to add a 2% uphill slope. Click on reset, click on calculate, and we see what happens. So for this scenario where we have two slopes, 1% downhill, 2% uphill, we need to apply 5.4 meters at the lateral inlet. The EU is almost acceptable, and at the end of the lateral we will still have 3.69 meters, which is again acceptable because it's higher than the minimum pressure required for this product. Let's delete the slopes for a minute and click reset. That's it.